Lesson 17.1, Task 2. Graph quadratic functions of the form f of x equals ax squared plus bx plus c. All right, again, this is called standard form. We will look at that more. And a, b, and c are just numbers, remember. So the function of g of x equals 2x squared, so in this case a is 2, minus 4x, b is negative 4, minus 2, so c is negative 2, whose graph is shown in red, is related to the function f of x equals 2x squared minus 4x from task 1, whose graph is shown in blue. Okay, so f of x is the blue function. We looked at that in task 1. G of x is the new function, and we're going to look at that and see how it relates to f. And you can look at the graph and you can see here that the vertex here has went from negative 2 down to negative 4. So this negative 2 has moved f down 2 units to make g. All right, so it says compare the statements. The graph of f of x was translated blank to create the graph of g. So f was translated down 2 units to create the graph of g. Complete the equation comparing these two functions. G of x equals f of x minus 2, because it shifted down 2 units. How does this confirm what you observed about the graphs in part A? Complete the statement. The graph of g is a vertical translation down 2 units to the graph of f. So for any value of x, you would blank the value of f of x to find the corresponding value of g of x. So you would subtract 2. All right, and again, we can look up here and see blue is f of x, and if you take the value and you move down 2 units here, or if you move the x-intercept goes down 2, or this x-intercept goes down 2, or sorry, this x-intercept is 0 and goes down 2. But you can see that each point on there has just been shifted down 2 units. All right, so it says, what are the appropriate x-intercepts for the graph of g? All right, remember g is the new function. It's in red. So if this is negative 1, it looks like about negative 1/2. And this looks like about, that's 2 and that's 3, so that's about 2.5. So negative 0.5 and 2.5. And again, you find those by locating where the graph crosses the x-axis. All right, so is the statement true or false? The x-intercepts of g are the same as the x-intercepts of f. And the answer to that is no. See, the x-intercepts here are inside the red. The blue line is inside the red, so they do not cross the x-axis at the same place. So the x-intercepts are the same. That would be a false statement. And then it says, is this statement true or false? When you translate a quadratic function vertically, the x-intercepts are not affected. Well, they are affected because we had different ones, so that one is also false. All right, select the equations or words that complete the statements. The equation of the axis of symmetry for the graph of g is blank. Well, if we go up here and look, the axis of symmetry, remember, cuts through the vertex. So the axis of symmetry is going to be x equals 1 for both g and f. So for g, it's x equals 1. The axis of symmetry for the graph of g is the same as the axis of symmetry for f. Translating a function vertically does not affect the axis of symmetry. All right, still cuts it in half to equal parts. All right, so what is the vertex of graph G? All right, again, I'm going to go back up and look just to make sure I haven't forgot anything. So G is in red, okay? I go over 1, down 4. So it's always x, then y. X is 1, y is negative 4. So 1, negative 4 is the ordered pair that represents the vertex. So 1, negative 4. And then it says complete the statements about the vertices of the graph. The vertex of graph blank is 2 units lower. So G is 2 units lower than the vertex of F. When you translate a quadratic function vertically, the vertex changes. So the vertex does shift down 2 units. Even though the axis of symmetry is the same, the vertex moves down 2 units. All right, that's all for task 2. If you have any questions, let me know. Lesson 17.1, task 3. Graph quadratic functions of the form f of x equals negative, in parentheses, ax squared plus bx plus c. All right, so suppose you multiply g of x by negative 1 to get h of x. The graph of g and the graph of h are shown. All right, so you can see they took the exact same function and all they did was multiply it by negative 1. So you can notice what happens to the graph here. G of x is the one we used in the last task, and h of x is the one that we've multiplied by negative 1. You can see that the x-intercepts are the same. It has the same axis of symmetry, but the vertexes are different now, okay? And you can see that this one opens up and this one opens down. So these are basically just a reflection across the x-axis. You can see if you take the red one and you just flip it over the x-axis, you will get the green one. Okay? So it says, how are the graphs of G and H related? The graph of G is translated up 8 units to create H. Nope, that's not it. The graph of G and H are reflections of each other over the x. That seems correct. The graph are reflections of each other over the y-axis. That is not correct, because that means they would be reflecting across this line instead of this line. So they would be reflected across the vertical line instead of the horizontal one. So it has to be reflection across the x. Which of the key features of the parabolist below are affected when g of x is multiplied by negative 1 to get h of x equals negative g of x? Select all that apply. So the intercepts were the same. The axis of symmetry was the same. The vertex was in a different place because it reflected across the x, so it moved up. And the direction went down instead of up. So the vertex and the direction of the parabola are the two things that changed. You can see the vertexes are opposite each other, and one turns down and one turns up, which indicates the direction. So that one was short, so that's all for task 3. If you have any questions, let me know. Lesson 17.1, task 4. Solve quadratic equations graphically. A zero of a function f is any number x such that f of x equals 0. So when your y value is 0, here's y. So y at 0, okay, that's why it's called f of x equals 0. These are both going to have y values of 0. And remember, f of x is just function notation. All right, the zeros of a function are the x-intercepts of the graph of the function. For a quadratic function, f of x equals ax squared plus bx plus c, any zero of the function satisfies the equation ax squared plus bx equals c plus c equals 0. Therefore, to solve the quadratic equation ax squared plus bx plus c equals 0, identify any x-intercept on the graph of the related function. F of x equals ax squared plus bx plus c. All right, so this is just an example. Okay, normally there would be numbers here, but they're just saying x1 and x2 because this represents two different zeros or two different x-intercepts. So this point tells you that x1 is an x-intercept of the graph of f. It also tells you that f of x1 equals 0. So x1 is a zero of the function. And the same thing applies for x2 is a zero of the function for the same reason. All right, it is important to understand that any solution acquired from a graph must be considered an approximate solution unless it's verified by substitution to be an exact solution. So it says solve 3x squared minus 18x plus 15 equals 0 graphically. All right, the solutions of the equation are the zeros of the function f of x equals 3x squared minus 18x plus 15, which are graphically represented by the x-intercepts. All right, so if you graph this function, it appears that 1 and 5, so here's 0 and 2, so halfway between 1 and 2, or 0 and 2 would be 1. And here's 4 and 6, so halfway between 4 and 6 would be 5. So they're saying that the x-intercepts, or the zeros, are 1 and 5. Okay? But they want us to verify that to make sure. So if we want to verify that, you can check that by hand or using your calculator very quickly. All right, so if you type in 3 and then times 1 squared minus 18 times 1 and then plus 15. So you can see that I just took 1 and substituted it for x and substituted again for x here. And if this equals 0, then 1 is a 0 of our function. And the other point was 5, so let's check 5 as well. So we're going to take the same function. We're going to do the exact same thing. Replace x with it. And that one gives you 0 as well. So you can visually see that it appears that 1 and 5 are your zeros, but this tells you that that is your two answers exactly by checking those algebraically. All right, how do you know that 1 and 5 are the only x-intercepts? The graph of a quadratic function is a parabola. It has one point where the direction changed, so it either goes down and back up or it goes up and back down. So one point where it changes directions, therefore the graph can cross the x-axis at most 2 times. All right, how do you determine an approximate viewing window or an appropriate viewing window when graphing the function? All right, so you're looking for the x-intercepts. So you can zoom in or out so that you can see the vertex. You can zoom in or out so that you can see the x-intercepts. But if you're looking for the zeros or the x-intercepts, you want to see where the x crosses the x-axis. So you can change the window to make that work. All right, so they went through the process of plugging in 1 and 5 to show that those are solutions as well. So both 1 and 5 are your zeros or your x-intercepts. All right, that's all for task 4. If you have any questions, let me know.